Artificial intelligence refers to various technologies, software, and computer systems that embody human intellectual abilities in computers. At a meeting at Dartmouth College in the US in 1956, John McCarthy first referred to artificial intelligence. He defined it as making machines behave like they do in the knowledge of human behavior. And the British mathematician Alan Turing suggested that computers can think like humans and argued that computers should be considered capital of thinking if they cannot be discussed by the conversation. This theory has been the basis for the field of the artificial intelligence so far, and it is used as a measure for demanding artificial intelligence under the name of the Turing test. Like human intelligence, artificial intelligence has three characteristics: problem-solving ability, learning, and universality. First, problem-solving ability. It refers to intelligent actions, actions to solve problems such as calculating formulas, juggling targets in pictures, understanding AlphaGo's board, and determining the next number. Next, computer vision. One of the large number of the uses of AI in technologies is the ability to review and interpret the content of an image via pattern recognition and deep learning. Computer vision let AI systems interpret components of visual data, like the captures you will find all over the web, which learned by asking humans to help them identify cars, crosswalks, bicycle, and mountain, and so on. Learning in the past, people would all program themselves to realize intelligence, but it was impossible for humans to design if the problem was complicated. To solve this problem, we create a model that automatically identifies results given data from inputs and outputs. This is machine learning and deep learning. It is a feature of artificial intelligence that can be applied in various fields by modifying deep learning models. Machine learning, a significant application of AI that lets computer systems, programs, and applications learn automatically and develop better results based on experience, all without being programmed to do so. Machine learning allows AI to find patterns in data, uncover insights, and improve the result of whatever task the system has set out to achieve. In order to achieve two things, one thing is called algorithm. Algorithm is a step-by-step procedure that defines a set of instructions that must be carried out in significant order to produce the desired result. The use of algorithms in AI is fundamental basics. They are used to analyze data, to gain insight, and to subsequently make a prediction or create a determination with it. It is these algorithms that tell the machine how to learn on its own. For each category of task, we can use significant algorithm. In the below sections, you will understand how a category algorithm can be used as a solution to complex problems. Artificial intelligence algorithms can be broadly classified as classification algorithms, regress algorithms, and coroutine algorithms. The classification Algorithms is a technique that is used to identify the category of a new observation on the basis of the training data. In classifications, a program learns from the given data sets or observations and then classifies new observations into a number of classes or groups, such as yes or no, 0 or 1, span or no span, cat or dog, and so on. Classes can be called as a targets, labels, or a category. Unlike a regression, the output variable of classification is a category, not a value, such as a green or blue, fruit or animal. Since the classification function algorithm is supervised learning technique, so it takes label input data, which means contains input with the corresponding output. In classification algorithm, a discrete output function is mapped to input variable. The main goal of the classification algorithm to identify the category of give a dataset. And these algorithms are mainly used to predict the output for the category data. Classification algorithms can be better understand understood using the block diagram. In the block diagram, there are two classes, class A and class B. These classes have features that are similar to each other and dissimilar to other classes. In the classification algorithms, artificial intelligence classes a new category of versions based on existing data which can code as training data as well. Classification uses an array of algorithms. A few of them listed below: Navier-Bayes decision trees, random forest, and logistic regression support vector machines, k-nearest neighbors. Here I will simply talk about two algorithms. One is the random forest, the other is the decision tree. Random forest. Random forest works like a group of trees. The input data set is subdivided and fit into different decision trees. The average of output from all directions trees is considered. Random forests offer a more accurate classifier as compared to decision trees algorithm. An advantage of using random forest is that at least the problem of overfitting which was present in a standalone decision tree lead to much more robust and accurate classifier. As we can see in the above image, we have 5 decision trees trying to classify a color. In this case, we take the average of all the outputs, which gives blue as the highest weightage. Linear regression is the most simple and effective regression algorithms. These use the gauge two quantities such as cost of houses, numbers of cores or out deals, and so forth. In view of constant variables, linear regression algorithms choose a linear relationships between an independent and one or more independent variables, hence called as linear regression. Since the linear regression shows the linear relationship, which means it finds how the value of the dependent variables is changing according to the value of the independent variable. So many algorithms. Where are they used in our real life? Simple. First of all, Booking.com has a lot of machine learning methods everywhere on the site. They try to predict users' intentions and recognize intents. Where will I go? Where do you prefer to stop? What are you planning to do? Some predictions are made even if the user didn't type anything in the search line yet. But how did they start to do this? No one can build a huge complex system with various machine learning algorithms from scratch. They have some statistics and created some simple models at first step. Most of the features at such services like Booking.com are rather clear than numericals. Sometimes it's become necessary to predict an event without significant data about the users. For example, all the data they have is where the user is from and where she wants to go. Logistic regression is ideal for such needs. Here are some histograms of logistic regression trying to predict a use will change a journey data or not. The following example is applied to clustering algorithms pamphlet. You know the junk folder in your email inbox. It is the place where your emails and that have been identified as spam by the algorithms. Many machine learning courses, such as framework courses, use the spam filter as an example of unpersuaded learning. What the problem is, spam emails are at best an ignored part of the modern days marketing technique. In other words, an example of people preaching for your personal data. To avoid getting these emails in your main inbox, email companies use algorithms. The purpose of these algorithms is to flag an email as spam correctly or not. How it works. K-means clustering techniques have improved to be an effective way of identifying spam. The way that it works by looking at the different sections of the email, handle, sender, and content. The data is then grouped together. These groups can be classified to identify which are spam, including clustering in the classifications progress improve the accuracy of the filter to 97%. This is the excellent news for people who want to be sure they are not missing out their favorite newsletters and offers. So now algorithms are so common that new problems arise in our lives. For example, who is to blame if something is going wrong? Let's take the most obvious example, self-driving cars. Who should be held accountable in the event of a traffic accident? One thing is clear, ML cannot make difficult, ethical, or normal decisions on its own. In the not too distant future, we will have to create a framework to solve ethical connection about ML technology. With all these limitations, is ML worth using? It cannot be denied that AI has opened up many promising opportunities for humanity. However, it is also leads some to philosophy lies that machine learning algorithms can solve all humanity's problems. Machine learning systems work best when applied to a task that a human would otherwise do. It can do well if it isn't asked to be creative or use common sense. Algorithms learn well from eclectic data, but it doesn't understand the world and how it works the way we humans do. For example, an ML system can be taught, well, what is a cup look like, but it doesn't understand that there is coffee in it. People feel this limitations like common sense and intu- intuition. When they interact with AI, for example, chatbots or voice assistants overfilled when asked responsible questions that involve institutions. Autonomous systems have blind spots and fail to detect proactive that a person would immediately notice them. The power of the machine learning helps people do their jobs more effectively and live better lives, but it cannot replace them because it can't perform many tasks. This is on my speech. Thank you for watching.